Hi everyone, my name is Nuno. The topic we're going to discuss today is unlocking the secrets of sleep, a data-driven exploration of its impact and influencing factors. So first things first, why sleep? As we all know, sleeping is just so important. It is a foundation of healthcare closely relating to our mood and health status. There have been many related studies going on about this matter. As you can see, it is a very old and important topic. Personally, me myself has been a bad sleeper. I have a very messy sleep schedule and suffered severe headaches because of this. I want to address the importance and find solutions for me and others. And as I looked around the internet, I found that many people are in the same situation as well. Research showed that about a third of the adults lacked of sufficient sleep. Especially for us university students, 70% don't sleep enough. I also looked up statistics from the Hong Kong government. As you can see from the graph, about 35% of the people sleep less than 7 hours, which is not enough. So now let's look at the data science questions that we're going to answer today. First, how can I utilize data science to demonstrate the importance of sleep? Second, what are some main factors affecting our sleep? The datasets we're going to use today come from Kaggle. For question 1, we're going to use the Sleep, Health, and Lifestyle dataset. For question 2, we're going to use the Sleep Efficiency dataset. We'll be using R for data analysis. We will implement data visualization with ggplot2 package. We'll also use regression to statistically identify and visualize the relationships when it comes to factors and effects. We'll use the LM-CoF functions from R. So now, without further ado, let's get into work. For the first question, demonstrating the significance of sleep with data science, I created two plots here. The first one shows that longer sleep duration correlates with lower stress, and the second one is a box plot showing the sleep quality by BMI category. This can show that sleeping relates to both our mental health and physical health, as longer sleep relates to lower stress levels and poor sleep quality may relate to obesity. So these graphs using data science can convincingly show that sleeping really does have an impact on our health. For the second question, discovering the underlying factors affecting our sleep, we can use similar approaches as the first question, using data visualization to depict a graph. As you can see here, this is what we've done on the screen. However, this may have some drawbacks. If we want to identify each factor, we need to go through the redundant process for each element in the dataset. And the results are hard to quantify, because for example, if I want to compare the effect of exercise and caffeine intake, we cannot use this kind of box plot, as maybe we could see that they both have an effect, but the comparison might not work or be inaccurate. So the solution that I found was to use a correlation heat map. Now this has several advantages. First of all, the correlation is a number, so that it shows the relationship in a very simple format. And this number could be quantified, and you can compare the correlations. So the results are comparable. Now let's get into work to creating the correlation heat map. The first step is data cleaning. Regressions are calculated between sets of numeric values. So we need to change the data into numeric. Many data in the set originally are not numbers. There are times in standard R format for representing sleep time and wake up time. There are yes or no's for representing if the person was a smoker. A trouble I met when cleaning this was the conversion of time, because many people slept after midnight, and this would be considered into early sleeper if you just divide it by 60. So the approach I carried out was to do plus 24 if the time was from 0 to 12. This was to make sure that sleeping after midnight is not considered early sleep. So now let's fit the clean data set into the heat map. Also make sure to make the variable names smaller so that they don't overlap with the map, which would look very bad. And finally, here is our heat map. So what can you notice upon first looking at this map? Something you can notice here is that life habits affect sleep efficiency rather than duration. Sleeping efficiency here denotes this time asleep over the time on bed. This is because duration have very low correlations to other factors, except wake-up time, of course, because the later you wake up, the more you sleep. The positive drivers for sleep efficiency are exercise and, for somewhat reasons, caffeine's intake. The negative drivers here are alcohol, bedtime, and wake-up time. So early sleep and early wake-up facilitates sleep efficiency. Let's analyze something that is against our incentives. Why is caffeine positive? Some guesses here that I made according to the dataset is that dataset is not large enough, so it might not represent the statistical truth. And people who drink coffee might be more busier, and so they're more tired at night. Or maybe coffee does not affect sleep that much unless if you're a very heavy drinker. It turns out that the third guess might be correct. I depicted a bar plot of the distribution of coffee drinkers in this dataset. I found surprisingly that there were no heavy drinkers, as no one took over 200 mg caffeine. Finally, let's move on to the conclusion. According to our data analysis for question 1, sleep plays an essential role in health. There are many health factors that are related with sleep. According to the analysis for question 2, we can conclude some do's and don'ts for a better sleep schedule. We can form an active exercise schedule and go to bed at an early time. We shouldn't drink or smoke or wake up too late. However, our analysis has some limitations. For example, when analyzing the relations for factors like stress, reciprocal causation appears. High stress caused low sleep efficiency and the same backwards. We don't really know who's the reason of who. And small data sets that we use may result in less statistical power and inaccurate results. Thank you very much for listening to my presentation.